Hi everyone, I will solve GATE 2015 Aerospace Engineering question number 63. For a normal fork relation between the upstream Mach number m1 and the downstream Mach number m2 is given by m2 square equal to gamma minus 1 m1 square plus 2 upon 2 gamma m1 square plus 1 minus gamma. For an ideal gas with gamma equal to 1.4, the asymptotic value of downstream Mach number is. This formula is related to normal shock wave. To know more about it, you can refer to this NPTEL lecture. First, we will see what is a normal shock wave. If there is discontinuity in the flow properties, then one shock wave is generated, and across the shock wave, properties changes. So there are some assumptions related to normal shock: steady flow, that is 1D flow, that is inviscid flow on upstream and downstream part. In between the shock, it is highly viscous, and the flow is adiabatic. There is no external shaft work, and the gas is calorically perfect gas. So if in the upstream there is Mach number m1, in downstream it will become m2, and properties are also corresponding p1, v1, t1 and ρ1. In the upstream property are denoted by 1, downstream by 2. If we take the control volume around the shock wave, and then we can derive the governing equation. Continuity equation will be ρ1 v1 equal to ρ2 u2. Momentum will be v1 plus ρ1 v1 square equal to p2 plus ρ2 u2 square. Energy equation will be h plus u square upon 2 equal to constant. This is also called stagnation and enthalpy. And the enthalpy is given by Cpt. And equation of state is given equal to ρRT. This is the perfect gas equation. So now if you see in the problem, this relation between upstream and downstream Mach number is given, which is m2 square equal to gamma minus 1 m1 square plus 2 upon 2 gamma m1 square plus 1 minus gamma. So if we draw the plot between m1 and m2, we will get this plot. So here you can see there are two. If asymptotic line can be two, one is this and one is this. So there can be one supersonic Mach number and one subsonic. But if we see from the entropy, then if m1 is less than 1, then entropy is negative. As entropy cannot be negative in a process, hence Mach number m1 will always be greater than 1. So for m1 greater than 1, only asymptotic Mach number is corresponding to m1 tends to infinity. So we will find at m1 tends to infinity what will be the value of m2. So we are given m2 square equal to gamma minus 1 m1 square plus 2 upon 2 gamma m1 square plus 1 minus gamma. We will divide by m1 square in denominator and numerator, then we will get gamma minus 1 plus 2y m1 square upon 2 gamma plus 1 minus gamma upon m1 square. If we take m1 tends to infinity, then this term will be 0 and this term will also be 0. It will be gamma minus 1 upon 2 gamma. So our m2 is under root gamma minus 1 upon 2 gamma for m1 tends to infinity. We will put, we are given the problem gamma is 1.4. So we will put value of gamma here. So it is under root 0.4 upon 2 into 1.4. If we put this value in the calculator, we will get this value 0.37796. So our asymptotic downstream Mach number will be 0.378. This is the answer. Thank you.